Welcome. Today we're looking at the additional mathematics very first paper when it started way back in the year 2012. So we're going to work through this add math paper and yeah, it's nice and easy. So this paper has four sections and well, 5 sections, and you should do everything from section 1, section 2, section 3, and then the final section you choose one of 2 questions. But for our sake, we'll do everything. All right, so let's get into it. So as you can see, this is section 1. Section 1 constitutes of 2 questions. The 2 questions will be relations and functions, factor and remainder theorem, surds, logs, indices, linear reduction. That will be question 1. Question 2 is like quadratic equations, inequalities, sequence and series. That's generally in question 2. All right, so section 1 is really just algebra. Section 1 is algebra. So let's go ahead and do this question. So it says the functions f of x and g of x are defined by f of x is x cubed plus 1, but f of x is defined between 0 and 3, and g of x is equal to x plus 5. And then it says, where r is the set of real numbers, determine the composite function g f of x. So the composite function g f of x means we're putting g into f. That's all it means. So let's do that. So the composite function g f of x means we're putting f into g. G f of x, this is what we want. So we're going to put f into g. All right. So this will be equal to g of x is x plus 5. So g f of x is going to be f of x plus 5. That's going to be g f of x. So we'll put f of x into g, and f of x is x cubed plus 1. So this is going to become x cubed plus 1 plus 5. X cubed plus 1 plus 5 is x cubed plus 6. And that is g f of x. It then said, state the range of g f of x. It wants the range. Now, first thing I want to tell you is before you can find the range, you need to know the domain. All right? The domain of g f of x, the domain for this function, the domain is going to be x, and x is going to be between 1 and 3. This is the domain between 1 and 3. That's the domain. The domain of g f of x will be the domain of f of x. So this is the domain. So the domain is what we're going to use to find the range. All right. How do we use the domain to find the range? So that means then g f of x, this is how we're going to find the range now. G f of x is of course going to be between, first thing you need to do is find out what is g f of 1. G f of 1 will be put 1 cubed plus 6, that's 7. And then put in 3. 3 cubed is 27, and 27 plus 6 is 33. And so this is the range. G f of x is between 7 and 33. This is the range. All right, this is the range of g f of x. And that's the answer. Nice and easy. The next part is asking us to determine the inverse of this. For the inverse, which is quite simple, we're going to call g f of x y. All right, we're going to call y is equal to x cubed plus 6. So y is equal to x cubed plus 6. To find the inverse, the first thing they tell us to do is interchange x and y. So what we're saying is then x is equal to y cubed plus 6. And then we need to make back y the subject. To make y the subject, we're going to subtract 6 from both sides to get x minus 6. And that's equal to y cubed. But then we need y. X minus 6 is y cubed. So to get y, we're going to have to cube root both sides. And so this is y. All right. Now this y is the inverse. This y is the inverse. And so what we can therefore conclude now is that g, f, the inverse of this, the composite function inverse, is going to be equal to the cube root of x minus 6. That's the inverse, the cube root of x minus 6. Nice and easy, soft. Nice and easy, no issues with this question. So it's the cube root of x minus 6. All right, now let's continue with part B now. Part B. Part B, the next part of the question, is asking us if x plus 2 is a factor of f of x, find the value of a. All right, if x plus 2 is a factor of f of x, find the value of a. That's part 2. Now, if x plus 2 is a factor of f of x, then what that means is that f of minus 2 is equal to 0. F of negative 2 is equal to 0. How do we know that? F of negative 2 is equal to 0 because x plus 2 is a factor. And so we're going to substitute in the function for f of x. We're going to write 2 times negative 2 cube, 2 times negative 2 cube, minus 3 times negative 2 square, minus 4 times negative 2 plus a, and of course this is equal to 0. And this is how we're going to find the value for a. And that's equal to 0. So let's now continue now. So negative 2 cubed is 8. 8 times 2 is 16. And then minus 2 squared is 4. 4 times minus 3 is minus 12. And then minus 2 times minus 4, that's positive 8. Plus a, and that's equal to 0. Nice and easy. So all we need to do is find the value for a now. So 16 minus 12 plus 8, that's 12. And so a is equal to negative 12. That's the value for a. A is equal to negative 12. And that's all they're asking us to do. Nice and easy. Soft. And so that's the solution of the first part so far. Now let's have a look at part C. Part C says to solve the equation 3 to the 2x minus 9 times 3 to the minus 2x is equal to 8. So let's see how we solve this now. So first thing I recognize is, well, 9 times 3 to the minus 2x, by laws of indices, I can rewrite that a different way. So I'm just going to rewrite it back as 3 to the 2x minus 9. And instead of saying times 3 to the 2x, I'm going to write minus 9 over 3 to the 2x. 3 to the minus 2x can be written as 1 over 3 to the 2x. So I can write it this way, and that's equal to 8. Nice. So now I have this equation to solve. To solve this equation, I'm then going to multiply the entire equation by 3 to the 2x. So multiply this equation now through by 3 to the 2x. By multiplying this equation through by 3 to the 2x, I'm going to have 3 to the 2x all square. So now I have 3 to the 2x all square minus 9 is equal to 8 times 3 to the 2x. Nice and easy. All we did was multiply through by 3 to the 2x to make the equation easier for us to solve. Now I'm going to call 3 to the 2x y. Just call it y. All right? It looks complicated with the 3 to the 2x and all of that stuff. So we can say, let y be that 3 to the 2x and see if we can solve it a little more easier. If we call 3 to the 2x y, then the equation above is going to become y squared minus 9 is equal to 3 to the 2x is y, and so it's equal to 8y. Now this looks very easy to solve. This looks like a quadratic equation. So now it just looks like we have y squared minus 8y minus 9 is equal to 0. Now this is so easy to solve. This becomes so easy to solve because now we can factorize it and say this is just y minus 8 okay, to get y minus 9, sorry, and y plus 1. Y minus 9 times y plus 1. Those are the two factors. So we factorize it, and this is what we get. Y minus 9 times y plus 1. And that's, of course, equal to 0. Nice and easy. Now that we have this now, it is easy to solve for x. It's very easy. All right? So we just need to remember that, of course, what was y? Y we said was 3 to the 2x, all right? So when you're saying that y is equal to 9, in reality, what we're saying is 3 to the 2x is equal to 9. This is what we're really saying. But if 3 to the 2x is equal to 9, x must be what? X must be 1. That's the only way 3 to the 2x can be equal to 9, because if x is 1, this is really 3 squared, and 3 squared is 9. From over here, so now we're really saying that y is negative 1. And if y is negative 1, then what we're really saying is 3 raised to the power of 2x is negative 1. But if 3 raised to the power of 2x is negative 1, this is not valid. This is crazy. All right, this is crazy. This has no solution. You can tell them. Don't be afraid to say that this is crazy. All right, and so the solution is x equal 1. This is crazy. You cannot raise a number to a power and get a negative answer. So this is crazy. Now, once you finish and you get that x is 1, you can test your answer. So put 1 in here. 3 to the 2 is 9 minus 3 to the 2 is 1. 3 times 3 squared is 9. 9 over 9 is 1. 9 minus 1 is 8. So you know your answer right now. So x is indeed 1. All right. So you can just tell them. So the answer is x equal 1. That's the solution. X equal 1. Nice and easy. And that takes care of part 2. This is 5 marks, by the way. Now part 3. Part 3 of the question, it's asking us now, it says express x cubed minus 10 raised to the x minus 3 in a log form. Okay, So it wants us to express x cubed, which is equal to 10 to the x minus 3, and they want us to express this in log form. Now, in order to express this in log form, what are we going to have to do? The first thing we can do, always just take log of both sides. Take the log of both sides. Let's just take log of both sides. By taking log to base 10 of both sides, we're going to get log to base 10 of x cubed. Log to base 10 of x cubed is equal to log to base 10 of 10 to the x minus 3. Now don't worry at all. Now this is very easy. Now according to log, we can bring down the power, and so we can rewrite this as 3 log to base 10 of x is equal to, we can bring down the power right here, the x minus 3, and write this as x minus 3 times log to base 10 of 10. But now look at this now, guys. Log to base 10 of 10, this part right here is 1. Log to base 10 of 10 is just equal to 1. Nice. And so 3 log to base 10 of x is just x minus 3 times 1, which is just x minus 3. So this is now log to base 10 of x. Okay? Now we need to get rid of this 3. So to get rid of this 3, we divide both sides by 3. So we're finally going to get that log to base 10 of x is equal to, when we do the division, it's going to be equal to 1 over 3 times x. Because we divide both sides by 3, x divided by 3 is 1 over 3x, minus 3 divided by 3 is 1. And so this is the solution for part 1. All right, so log to base 10 of x is equal to 1 over 3x minus 1. Now the next part of the question says, hence state the value of the gradient of the graph of log to base 10 of x versus x. Now guys, if this was a graph, or if we were plotting this as a graph and this is y, we know the equation of a line is y is equal to mx plus c. Y equal mx plus c. And so clearly the gradient of this line, can we just call the gradient m? We can if we want. Just call the gradient m. So the gradient, I'm going to write grad for gradient. The gradient is just 1 over 3, which is 2ez. Nice. So this is all we have now. This is the gradient. Nice and easy. Soft. All right. That's the gradient. That takes care of the third part. And so this takes care of question 1. No issues with question 1. Nice. Now let's go on to question 2. Question 2, it gives us a quadratic equation